my slide now. You just need to confirm that my slide is visible so that I will know we are together. Can you see my slide?
Yes, sir.
Can you see this slide? Okay, fine.
Yes, sir.
Yes, sir.
All right. Yes, I'm aware that this class started on Monday. I was in the class at the beginning and noted the fact that two of us had to take, but one after another. That was communicated to you. My colleague, Dr. Abba, has finished her part, and I'm going to continue from where she stopped. But by way of brief recast on what I'm aware she has done, I'll just mention part of what she has done before. And that includes the fact that the course we are dealing with is ENS 723, titled Municipal and Industrial Waste Control. And in her interaction with you, you were taking through the course content Please, sorry, class. I hope you heard my excuse that you needed to excuse me. We are undertaking another training, the track B training in Makurdi and Jos. And I'm involved in the planning and some aspect of implementation. So, and there was an issue that needed my attention. I was called to respond to. That is why I had to halt my interaction with you. I hope you will excuse me or pardon me for that.
No problem, sir.
Are we together?
We are together, sir.
Yes, sir.
All right, that's fine. So, just as I was saying, as a highlight of what I learned she did with you, I'm just mentioning this aspect, believing that it will just be a confirmation that yes, my information is correct. Conceptual clarifications were also made as to the terms related to this course. You were taken through that to the characteristics of municipal waste and basic or general principles or criteria for municipal solid waste management strategy. The hierarchy of waste management was also taken, as well as the integrated sustainable waste management. The institutional framework related to that was also taken by my colleague. The functional elements of solid management, solid waste management were also considered. There were discussions or interactions on waste minimization approach. You looked at the various ways and then the advantages of benefit you are also considered, and specific explanations were given to the terms related to that. Recycling of waste was discussed to a point of recycling chart and close cycle management of substances. You looked at that the benefit of that as recyclables from the waste stream were also considered, and the material recovery facility was during her interaction with you. Compositing was also taken, and its associate benefits and the raw material for compositing, and then the aspect of anaerobic digestion factors affecting that, and then landfills were considered from open dump to sanitary landfills, where you considered the various types and then the characteristics associated with these various types of landfills or waste disposal processes. You concluded with an assignment which I'm going to emphasize, or I'm emphasizing that you should take it serious, because this assignment will serve as your continuous assessment for this course, which should be submitted, and it will be graded as part of your exam scores. Having said that, I think I have given a recap of what I understood that my colleague took with you. Does that align with your understanding of how you fed the class? Or you
Yes.
have a contrary opinion?
No, sir.
What's the answer?
Yes,
No,
sir.
sir, that's all with you, sir.
That is okay.
Sir.
All right. So I am going to continue from there. And I will encourage you to make the class interactive. You'll be free to share your opinions. You'll be free to ask questions, and then we can reason over the concepts that we are going to take in the course of this class. What I will also consider that you should be conscious of is that participatory engagement in the class enhances understanding, and then also provides opportunity for your own individual experiences to be shared among the group. So if you have experience that can benefit the class, or you have areas that we need clarification, please don't stay back with those things. And again, to make the class much or well organized, I would expect that you should be familiar with these basic tools. When you want to speak in the class, indicate by raising of your hand. By the time you finish, you drop your hand. This will serve as a way of moderating the class orderliness, as well as making you to get familiar with the use of the the online platform for class engagement. So the more you are able to utilize these tools, the more familiar you become and the better for all of us. So take note of those things. So I'm going to put it on slideshow now so that it may be more visible. The visibility, is it better now?
Yes, sir.
All right. I'm trying to see how I can clear this part that is covering part of the presentation. Okay, so this one we'll be looking at the content of a typical landfill. If you recall, we're just coming from what my colleague has done, which is the one we have run through. And from where she stopped, and the next thing is what I have projected. The site assessment, typical landfill design. It has a component of site infrastructure
Any problem in the class?
Hello, good morning. The lecturer has been thrown out. He just called me. He's trying to log in back. Let's exercise patience. Thank you.
Okay.
Out and reconnection became an issue. Sorry, please. The network, and then the link was no more available at all for me. I had to call for technical assistance for me to reconnect back. I'm happy that you people were still on while that challenge lasted. Thank you. So we're back to continue. I hope you're hearing me.
Yes, sir.
Hello.
Yes, sir.
Okay.
Yes, we can hear you.
So if you look at these terms, they are related to land fee, and it has to do with a specific site which has to be assessed before the uh, establishment of the land fee. There are certain instructions that that have to be in place for that. The infrastructure that is required for this to work will be together with the gel membrane. Then the compacted clay liner plus the asphalt liner, and then the geosynthetic clay liner plus these are just the various ways that the base sealing system is designed. It is recommended to design a spatial horizontal sealing element which cover the complete area of the landfill. These are to be installed in such a way that even after the landfills settle its base, landfill set closer than 1 meter to the groundwater table. As I've said, there is a tendency of the waste from landfill infiltrating into the pollutant from this waste infiltrating into water body, and it could be the surface water body and the groundwater body as a result of leaching of these pollutants. Geosynthetic clay liners are relatively new products in the field of landfill line. They are prepared clay liner sheets consisting of a thin layer of clay floor, approximately 1 centimeter, usually sodium bentonite, that is used in the production of these liners. And these are the sample pictures of the liners. The first one is the synthetic liner membrane, that is the geomembrane, while the second is the asphalt, then you have the clay. These are various types that can be used. Then, after constructing the landfill, there is a particular way of also compacting the waste in the landfills. Waste should be placed in layers and compacted as part of emplacement procedure. As part of organizing this in a way that is properly arranged in compartments and pressed to a level that these are not left loose in the landfill. It should not be dumped over a cliff-like working face. The waste should be deposited in only small working areas covered with sufficient soil into. Part of what compacting this is to prevent the solid waste to be blown off by air, or can easily be littered around by rodents because they can be taken away easily. The top figure shows an on-slope installation of waste. If you look at the figure here, you see that the top there is being opened, and then the compartment, if it is not properly done, that is how these things get loose and get circulated in the environment and become this diffuse pollutant or littered pollutant around the west, solid waste landfill. The unloaded waste is spread into thin layers of about 30 centimeter thickness and compacted. So this doesn't just happen. There are specific levels of thickness that are required, after which compartment, that is pressing down for that to become stable in the landfill, and where established so that it cannot easily be taken off by air or rodents or other activities within the landfill. Further compaction can be achieved by controlling the movement of collection vehicles close to the site. If the demolition debris and other dense rubble should be used to construct temporary haul roads across the site for collection vehicles to get the working first more easily. If you look at this, you require vehicles that will be coming in to discard the solid waste. If these vehicles don't have proper channels or proper routes to follow, then they can as well create a problem in the compartment or in the arrangement of these solid waste in the landfills. So that is emphasized. The strategic integrated solid waste management plan is what we are going to look at it next. And the strategy is the overall vision and objective. Then the action plan, implementation arrangement, and decision-making milestones. Together, they form what is called Municipal Solid Waste Management Plan. Then, by the right, we give a brief description or explanation of some of these things. The strategic plan itself can further be divided into two steps, which are the strategy and action plan. After you look at the whole strategic plan, it can be taken into sections. What are the strategies and what are the action plans that are involved? The strategy sets out the overall framework under which municipal solid waste management systems and standards are to be developed. That is what the strategy looks at. It comprises the vision of how the system will develop over a given period of time, like to say 15 to 25 years. There should be specific time frame within which that is expected to operate. Then the action plan gives details and specific options that are to be pursued to implement the requirements of the strategy. After the strategy set out the overall framework for municipal solid waste management system and standard which should be developed or complied with, then the action plan now gives details of specific options, what and what particularly should be done and at which stage, and failure of this particular option, what alternative is available. So those details are provided in the action plan. And the action plan set out the specific steps to be taken over a period of 2 or 5 years and may include investment projects. It also outlines the key decision-making milestones and design as indicators for project management. When you look at decision milestones, you are not looking at specific results that are expected within given time that will prove to you the success of the working of that particular landfill. Failure to see those indicators, then there should be alternatives that should be employed to ensure success or to ensure efficient function of the landfill. In addition, it may be desirable to prepare an immediate action plan covering the detailed program and flow of action over the first year or two. Just to highlight or to emphasize this, you look at the strategic plan is talking about a long-term period of over or of between 15 and 25 years. But in between this number of years, the action plans gives you indicators that will be used as assessing the the PG. If one would not have this action plan or indicators within the period of spread, you may have a long period of years, you come out to assess and discover that there was a failure. But this intermediate or periodic assessment gives you the opportunity to make corrections where there is need, so that a long-term objective is achieved. Hello, class, are we together?
Yes, sir.
Can someone
Yes,
confirm
yes,
that?
sir. Yes,
All
sir.
right. Thank
Well,
you.
with you, sir.
All right. Thank you. So we move on to the strategic planning methodology. If you look at this particular slide, I'm checking. If you look at this particular slide, we have a chart here that starts from number 1, and above number 1, we see what is called stakeholder consensus building. This is where the parties that are involved or affected by this project are engaged. Number 1 is to mobilize the planning process. And you can look at the flow chart, moving from the mobilization of the planning process. You define the baseline. What are the specific focus or elements or requirements that are needed for this particular project? So the baseline is defined. What and what should be considered as fundamental. Then you move on to establish identification of and evaluation of options. If you look at that point, there are there is setting up and down. After identifying and evaluating the options, there is a possibility that you now go on to develop the strategy. If at the point of development of the strategy, you discover that that is not workable, it has to be reconsidered. But how will you discover the workability or otherwise of that particular design or development strategy that is developed? It is when you are, yeah, there's a background noise. I don't know where it is coming from. I think I have to check. Who has not muted? Who has not muted? And then we are having that background noise. Is it from the system or from one of us? So check to see that you are muted, and then we only have to unmute when you have the need to speak. And when you have the desire to speak, you can indicate by raising up your hand. Yes, I can see that meeting has now been complied with. Now we go into having seen that the strategy has been developed. You assess the strategy to see whether it is workable. When that happens, you move on to preparing an action plan. You may recall our earlier presentation or explanation on strategy and then the action plan. The distinction or the difference between the two. Why the strategy is a broader, a bigger concept, the action plan is a subunit of the strategic plan. and it ensures a continuous or periodic assessment of the performance of the strategic planning or strategic plan. So when you now agree that a strategy has been developed, then you prepare action plan that can help you to have a periodic report regarding the implementation of the strategy. Implement the strategic plan. It is after the action plan is in place that you prepare the you implement the strategic plan. And further explanations are given by the left, where you have these things explained as I have gone through the chart. You can get more details from here. These are just further explanations relating to this. But I may just point out what specific stage is concerned with in summary is that the mobilization stage is concerned with how to get started with the strategic planning process. How to get started with that process will require getting input from stakeholders, getting people input from professionals, and then brainstorming on what and what should be considered primarily in the planning. Then defining baseline will focus or is usually focus on the understanding the basic or baseline situation and likely future requirement for this municipal solid waste management in the city. What and what fundamental that will be required and what should be expected in future as a necessary ingredient for the working of this, or as a reference for assessment. Aspects include waste quantities, waste operations, and shortfalls. So when you now look at what is available before you, is there enough waste quantity within the city, or there's small quantity of waste within the city? That will give you the span of the scale of the planning strategy, which strategic plan, which can accommodate what is available. So basic informations like this. Are there gaps that need to be filled in the course of implementing this strategic plan? Then, when you are talking about establishing the planning framework, it looks as the range issues that need to be established at the onset of the planning process. While identification and evaluation options are required to address the key issues being faced. These include waste collection, recycling, waste treatment, and disposal. As I've said, at this point, you are having this result as indicators where you can see the performance as used to assess the performance of the strategic plan. Then development of the strategy leads to development of the strategy, which must be agreed upon and accepted by all stakeholders. So when you are talking about developing a strategy, this stage must translate into a common position by all stakeholders. This is the integration of the opinions of the professionals and those that will be affected by that project. In some situations, you can see a landfill sited within a community that may suffer deprivation of their land. How are their feelings relating to this? These have to be taken into consideration. And then the possible impact of this project on the surrounding. For example, if you have a landfill within a community, the emitting gases being fed when they are not properly managed by the community is there. So those concerns will be taken into consideration, and appropriate measures that will mitigate the effect on the communities are also considered. Then the action plan will require the conversion or the re-implementation of the conversion of the ideas of the strategic plan into reality. That is translating into re-implementation with visible indicators that can show the success or otherwise of that. And then the implementation is once that is agreed upon, there is an implementation. There are interactive links between the various stages which stress the need for feedback. As I've said earlier on, those that the arrows that are indicating a connection from one point to another. Mobilization has a relationship to implementation because it is when people are well mobilized that they can support the project. And then identification, if you look at the chart again, the number 4 has a connection with the action plan. It is the identified options that can give you a guide to prepare the action plan. And you recall that periodically give a report on the performance of that particular landfill. That is where you see the feedback. Re-evaluation and are also required as the integral component of this process, because it is when assessment is done and feedbacks are taken, and then it is repeated after some time that we will see whether there is consistency, there is progress, there is expected result or otherwise. So these things are considered like that. Then we move on to the next slide, which is control of emission schematic of leachate treatment. We have established the fact that leachate will be associated with landfills. But when leachate comes out of landfills, what happens? What do we do? What is expected of us to do is what we are going to look at here. Leachate can be collected and treated before disposal. Leachate, which is unique of pollutant concentration and which may vary over time. Leachate treatment is one of the biggest problems of landfill management. And you look at the schematic here, it is giving us an idea about how process is done. You first have the number 1 landfills corpse, that is landfill site rated. Then leachate evacuation. After the landfill generates this, then we have, there should be a channel of landfill. And it is upon or after that evacuation that it is moved into the leachate storage pool, where it can be taken off for treatment in the leachate treatment plant. The schematic is there, the legend is down here, giving us the names of those locations as they are numbered in the diagram. Then treated water to sewage system and storage pool for sludge and sludge transport. So all of this, by the time this moves into number 4, which is leachate treatment plant, there is a separation of the treated water that moves into sewage system, and then the extraction of storage sludge, or of the sludge into storage pool. That storage pool collects the sludge that is left after water is extracted from the leachate. And then that is also for further treatment or for appropriate utilization as may be required based on the quality of the water that is obtained at that stage and for appropriate required application. Then sludge has to be transported after the treatment. It has to be taken to designated place where it, it is considered to be safe for disposal. Then we move on to this part of leachate treatment. And you can see the figure here. A leachate storage lagoon should be constructed. That is what I've said. After the leachate is collected, it moves into the storage. After treatment, there should be disposal to appropriate designated places. The storage capacity of the lagoon should be sufficient to contain all the accumulated leachate for long enough to reduce its pollution impact on the acceptable limit. Biological procedures can be used for this treatment. We have aerobic and anaerobic methods that can be used. Physicochemical procedures such as ultrafiltration, inverse osmosis can also be used. Thermal procedures with examples like evaporation and incineration. Then recirculation of leachate where it is necessary and safe to do that. That can also be done. Biogas generation, as I mentioned, is one of the possible consequences of landfills. Gases must be emitted as a result of the decomposition of solid waste in the landfills. How should this be handled? One feature of managed land of the waste will decompose anaerobically. When we are talking about anaerobic decomposition, we are looking at a situation where there is less of air presence or total absence of air. So occurs in the absence of air. That is, when we're talking of air here with a specific focus on oxygen. Anaerobic decomposition ultimately leads to the production of landfill gas, a mixture of carbon dioxide and methane gas. And carbon dioxide, which is carbon, also known as carbon 4 oxide, has its own advantage and also disadvantages. Methane is one of the poisonous gases that are generating concerns as how they affect the environment, including the weather condition, as well as traces of other gases are also emitted from the landfills. This gas from the landfill has to be monitored and controlled whenever there is a potential risk of accumulation of flammable concentrations in the site or from landfill gas migrations off-site. The natural tendency of landfill gas to migrate upward from those areas where waste is placed, eventually dispensing into the atmosphere. Its sites in sites where upward migration of the landfill gas is restricted, it will begin to travel laterally. And when that happens, there is also an effect towards its direction. And as I mentioned earlier on, the people within the vicinity of the landfill have some consequences to share from the processes that happen in the landfill. As the natural processes that happen that are associated with this waste that is disposed in the landfill. The natural tendency of landfill gas to migrate upward, I've said that one. On the landfill itself, no side building should be built directly onto the ground. That is a caution, one of the cautions that have to be taken. Biogas control and utilization. That should, the point I've mentioned earlier on, should emphasize the need for this landfill construction. There are people who will receive the and their opinions should be taken into consideration, and possible compensation or mitigation measures should also be taken. They're talking about control and utilization. Landfill gas management may be necessary for the minimum standard of site operation. However, where the quantity of landfill gas is large, more active methods of pump extraction, burning may be needed to control the migration of gas. Pump gas systems must be designed and operated by competent engineers. There are situations where the emitted gas becomes so concentrated in the environment that they have to be taken out. And these are possible ways that can be done that are mentioned here. We have pump extraction and then burning. These are alternatives. And this burning of gas is done professionally. It's not just to set fire around the place. And that is why there's a caution that competent engineers should be involved or should handle what has to be done. The basic concept is to install one or more vacuum pumps, which are also termed as blowers, to extract landfill gas. These pumps create pressure gradient in the landfill towards extraction wells to draw in landfill gases. And this is a professional design where this is transported by pressure. And then you have a pressure gradient that directs or determines the direction, are most often drilled into completed paths of the landfill, and each well is connected to a pipe system to the vacuum pump. The collected gas is drawn through pipes and landfill surface towards a flat stack where it is ignited and burned. So you can see the process, the collection and the eventual burning is a technical design that, if it is not carefully handled, can cause another undesirable result. Besides, it may be economic to use the gas for heating buildings as an industrial fuel, for steam generation, or for electricity production. These are also options that require professional engineering knowledge as well as the technical skills. So should also be noted as such. We move on to the next slide, which is the schematic of the control of biogas emissions. And as usual, the diagram is here and the labels indicating what the paths are also here. From the landfill cups and beds, where you have number 1, where gas is generated, you have biogas evacuation system. It is taken out from there through vacuum pump and then probably to electricity generator and then flaring, which is the combustion of that. And you can see that. And then you have that going up into the atmosphere. It is projected to a height that will be reasonable above the air surface to reduce the impact of pollutant from this burning on the environment. Biogas treatment and exploitation. Hello, class, are we together?
Yes, sir.
Can someone confirm that we are together?
We are to.
Yes,
All right.
Together.
we're
So
together.
this is, all right, thank you.
Are together, sir.
All right. Container with electricity generator by biogas. So this is a way of utilizing the biogas for meaningful application. Then there's a chart here which I have to look at. And what is this message? Yes. We go along if we are together. Okay, that is the response to my question. If you have a need to say something, you may chat or you may raise your hand. So thank you for feedback. Now we move on to the next slide, where this is just a pictorial presentation of what we discussed in the previous slide. Then what do we mean by incineration? Incineration is actually a systematic burning of substances. It is done under a under control condition and in a controlled environment. Incineration is normally an effective waste to energy element in an integrated waste management system. It is a way, it is a process that is considered meaningful in an integrated waste management system, whereby waste can be converted to energy. And when properly utilized, you see that what could have constituted an environmental hazard has now served as a raw material for a desirable product. The following items must be taken into consideration when looking into waste incineration as option. The incineration plant should operate continuously, that is 24 hours, 7 days a week, with only one period per year for maintenance to reduce the startup and shutdown period. The reason is that the emission greatly increase when the boiler is heated up or cooled down. This you may take example from our common experience in burning of substances. Where there is combustion, there is always what is called debris, known as ash. This ash is a pollutant, air pollutant or environmental pollutant of fine particles. So when there's a blowing of air, it increases its spread within the environment. So the start-off time for incineration requires fanning of the system for the burning to be ignited. And in the course of fanning, more of these particles, which are fine particles, are blown off, and can cause environmental pollution. And then again, in the course of cooling, there's also a high tendency of generating these emissions and spreading them within the environment. So that is one of the reasons why there's a caution on the number of times the incinerator should be cooled down or should be start off for the purpose of waste management. And then the reason for maintaining it on a continuous operation is again to require optimal utilization. For example, when you have an incinerator as an energy generating unit, you just imagine when the incinerator is put down or is put off, then the the energy generation is placed on hold, and then the optimum value of the product is also reduced, realize at that time the shutting down of the source. There's also another aspect. In the course of waste management through incineration, there's always a need to be sure that the incinerator will have sufficient supply of waste for it to continue to function. It is capital intensive to maintain incinerators. So whereby, and then also to build incinerators. So where incinerators are built and there is no sufficient waste to service it, then it amounts to underutilization, and then less value is obtained from what has been invested in that. So there is caution. And this decision comes from the baseline study that is done. If you look at the strategic plan that we considered before, there's a point where you establish the baseline. That baseline should tell you at minimum per day how much of the waste will be available, and that will determine the capacity of the incinerator that will be built, so that that capacity is maintained to optimum and there is no underutilization of the incinerator. Then long-term contract must be in place with waste generators for adequate supply. That is one of the things I mentioned, so that it avoids underutilization of the incinerator. There should be supply that will ensure that available. Then the energy content in the delivered waste must be sufficient. If the heat value is too low, then the support fuel might be needed to dry the waste. When the energy content is not sufficient to sustain the burning, then it will require alternative approach to ensure burning takes place. For example, when you have firewood fire, and then you have the dry ones, mid-dry wood inserted in the fire. The burning of the semi-dried one will depend on the amount of fire that is there, and also the number of the dry, so the available oxygen, whereby the other aspects are not sufficient to support the burning, then the effect of the ones that are not dried enough will reflect on the fire, and the fire will not burn strongly. And that is why when there is high fire, even something that is wet is put in the fire, it got burnt. When there is less fire, What is wet will be put in fire and will bring down the fire. And that is the type of thing we're talking about here. When the energy content is not sufficient, then we need an external or alternative source to dry the waste before burning can actually take place. But when there is sufficient supply of heat, even when the waste is not well dried, it can be burnt easily in the incinerator without a challenge, and you have a continuous supply of the required energy. Incineration would in that case be regarded more as a disposal uh, than recovery. Waste incineration boilers stroke furnaces are designed for specific heat value of waste to function properly. Then there must be a market for the produced electricity and heat. If you are looking at incineration as a way of generating electricity, then there should be a market for it. If not, you'll be wasting resources for no profitable value. But if there's a market for that electricity, it will serve as a way of maintaining, as a source of income from the incinerator, and also a self-maintenance strategy for the incinerator. Access to reliable maintenance of installation. Access to adequately trained operating staff, and then adequate access to disposal and reuse facilities. I mentioned some of these things when we are talking about consideration of land fees. Personnel staff are required, facilities are required. But when you have these facilities and you don't have the technical know-how in the maintenance of these facilities, then the guarantee for long-term usage is no more there. And then there's a schematic of the incineration flow chart here for us to look at. We look at waste storage, feed in preparation, combustion, and as I've said earlier on, ash will certainly be generated. And ash handling is considered as a unit of its own. And then after handling it, it is safely disposed. Then you have the gas temperature reduction and then heat recovery. There's heat that is associated with burning, and at a point that heat is recovered, and it can be put to use as appropriately required, or as a way of controlling environmental heat effect. Then air pollution control is a stage to that is necessary in the schematic of the incineration flow. And then scramble water or ash handling and disposal. You have the fan, and then emission is finally done in the stack. Then these are terms that I explained. Combustion, what does it mean? Blower steam turbines, the exhaust gas from the boiler, the dry or wet scrubber, and then activated carbon injection burger. These are explained here as indicated against the names. We may not take time to read through these lines because these are easy to understand terms. Selective non-catalytic reduction. This is the one which is a cause of urban smog. Is a situation where the atmosphere is densely populated with small particles to a point that there is a reduction of vision or visibility within the environment. Then we can talk about smog. And by reacting them with ammonia or urea, that is the process that is referred to as catalytic reduction, selective catalytic reduction. Backhouse filter, and then we are looking at a situation where the dust, this is filtered to remove dust and fine particulate matter. Then We'll move on to the next slide, which looks at the advantages and disadvantages of incineration. If you look at this, we have the advantages on the advantages on the right of my screen. When done properly, for processing phase for incineration. For other waste disposal or management processes, there is a processing phase where things like sorting and particle particle size determinations are necessary. But here, you just gather what has to be burned, introduce it into the incinerator, and then it gets going. So this process does not require necessarily the preparation or pre-processing stage. It can be located near large waste production centers, reducing transport costs and allowing the use of energy for heating purposes. That is as one of the advantages. It does not produce methane unlike landfills. Landfills result into decomposition. This incineration has been argued that it produces no methane emission. And there is little of methane. There's a tendency of producing methane, of course, but it's not very high. There are certain substances that can produce that. But if you look at the general equation for combustion, it is a combination of a particular substance with oxygen, resulting into the emission of a gas, which is commonly the carbon 2 oxide or carbon 4 oxide. And this carbon 2 oxide is produced as a result of the insufficient supply of oxygen, while carbon 4 oxide is produced as a result of the sufficient supply of oxygen. Where there is incomplete combustion, you have the carbon 2 oxide, and where there's complete combustion, you have that. But in a situation where this waste, in the course of this decomposition, when there is no sufficient heat that is applied, where I said is wet and you may need alternative drying process for the combustion to take place. That if it is a methane emission byproduct, then within that time you have a tendency of that emission. But on the whole, it is not a common source of methane gas emission. It allows the recovery of ferrous and non-ferrous metals in certain types of incinerators. Allow energy recovery in most incinerators, avoiding need for fossil fuel. Limitation of risks associated with handling of waste. Low sensitivity to variation in waste quality. These are some of the things that were implied in my explanations before. We talked about energy recovery. The flow chart I discussed presented part of that. The limited risks associated, you are not going to sorting, you are not going to pre-treatment processes. Therefore, once waste is gathered, is introduced into that, less exposure to it is considered. Then the disadvantages: operating problems at capacities lower than the nominal capacity in the case of fixed bed incinerators. Then residues and dust must be disposed of under suitable conditions. I mentioned those things before. While this is burnt, there are byproducts that are generated, the ash, and those things have to be handled properly. Emission of the to the atmosphere, just as indicated in the chart, there is eventual emission of gases in the atmosphere as a result of incineration. High investment and operating costs. It is very expensive to install it. And that explains why it should be put under optimal utilization, that there is no um, waste of time or underutilization in the implementation of incineration as a waste management or waste control measure. Once installed, little flexibility in terms of changing waste management approach due to high investment, because it requires very high investment. Once that is installed, it is difficult to begin to think about changing to other alternatives, because you have to put it to a long-term use before it will match the value of how much was used in installing it. Then these are just figures, illustrative cost for different municipal solid waste treatments. Landfilling takes about this much per ton, 20 to 30 US dollars per ton. Compositing takes 50 to 80%, 80 US dollars per ton, and the incineration 100. You can look at this graduation in cost, justifying the fact that incineration is really very expensive as compared to other alternatives for waste management. Then definition of hazardous materials. The United States Occupational Safety and Health Administration defines hazardous materials as any substance or chemical which is a health hazard or physical hazard, including chemicals which oh, this is serious. 50 to 70. Yeah. Including chemicals which are carcinogenic, toxic agent, irritant, corrosive, and all of these definition examples are here. And then when we're talking about a hazard, is something that has the tendency to cause harm. That is in summary. My battery is giving me warning, so I want to move to the next slide, and then our time to is high spent. We'll stop at a point. Differences between hazard and risks are indicated here. Hazard refers to a material or property that can cause an adverse reaction or effect. Risk refers to the likelihood of that effect manifesting along with conditions associated with it. In other words, we can talk about risk as a tendency of exposure to risk, while to hazard. While hazard is a substance that has potential to cause harm, risk is the tendency of one being exposed to that material which has that capacity. However, certain hazardous materials can cause different conditions depending on how they are stored, handled, or treated, disposed, and in which personal protective equipment is used to handle them, along with other conditions that can lead to that. The exposure to this will be dependent on how they are stored. Maybe the storage condition, when it is not safe, it can even ignite the potential harm that is in that particular material. Then we move on to hazardous substance may be found in different states. Could be physical state, such as gaseous, liquid, or solid, including sludge. The life cycle of hazardous substances can be regarded from cradle to grave, that is from the beginning to the end of its lifespan, covering all stages of its recovery from natural sources through its final disposal. A hazardous substance is considered hazardous when it is no longer usable. Hazardous waste when it is considered not usable again for its original purpose. It can be a hazardous substance but may be useful for a particular thing. Then when it is no more considered useful, then it becomes a hazardous waste. So that is what that point emphasizes. Then classification of hazardous waste characteristics. There are some that are given specific characteristics based on the Basel Convention which established these characteristics. Some are considered explosive, flammable, liquid, flammable, solid. Explosive, these ones can cause explosion. Flammable, they can ignite or fire easily, or they can cause combustion easily, or catch fire easily. Waste reliable, waste liable to spontaneous combustion. Waste emit. Let me see this battery now. So class, hello class. Are we together?
Yes, sir.
Hello. All right. I have a very
Yes, sir.
low battery level. So, and then we just have about 12 minutes to the end of the class. I wish that we stop here and note where we stop so that
Okay, sir.
we'll continue tomorrow. Order not to allow the battery to shut us down. We'll conclude the class properly. Any questions so far? Any question? Any hand up? No hand up. So please, I tell you bye-bye for today and hope to meet you tomorrow. No afternoon session. Thank you.
Okay, sir.
Are we together?
Thank you.
Yes, sir.
Thank you.
Thank you
So
so
have a
much.
nice day. We'll meet tomorrow.
Thank you, sir.
All right.
Thank you,
Bye-bye.
sir. Bye.
Thank you.
Where is this going to privately?
Bye.
Bye-bye.
Equal.